I should really be doing this. All right. End behavior. The limit of f of x as x approaches negative infinity, and the limit of f of x as x approaches infinity. What is this doing? As it goes left, what's it doing? It's going down. And as it goes to the right, it goes up. Right? Okay. Is this guy increasing or decreasing or constant? If I put my pencil on this and start here, from left to right, is my pencil going up or down? Just up. Which means it is what? Everywhere. What interval is it increasing on? From negative infinity to infinity. Okay? All right. So that is a linear or identity function. Now we go on to quadratic. Quadratic would be f of x equals what? X squared. Sure enough, x squared. So now, here we go. X, f of x. -2, -1, 0, 1, and 2. And somebody always says, you always use those same points? No, but those seem pretty good for this, don't they? If we plug in -2, what comes out? -2 squared, which is what? Thank you. It's like everybody's brain short-circuited at the same point. I'm glad y'all rebounded. -1 squared. 1. Law, y'all. Squared does not mean multiply by 2. Square means multiply by itself. So -2 times -2 is 4. -1 times -1 is 1. 0 squared. Oh, thank God. 1 squared. 2 squared? 4. So let's graph this. What should it look like? We know all quadratics look like what? That U thing, which is called what? Thank you. A parabola. All right. So, what is the domain? Thank you. Yes, thank you, Nick. It is all real numbers. From negative infinity to infinity. However, what is the range? This is the first time we've seen a range that's not all real numbers. From where? Y such that y is what? Yep, goes from here up, doesn't it? So greater than or where y is an element of the reals. You could also write this or 0 to infinity. They mean the same thing, don't they? Y-intercept. Crosses the y-axis at 0, and the x-intercept 0. Continuity. Is this guy continuous? Yes. Do I have to pick up my pencil at all once I put it down? So what interval is it continuous on? It just keeps going at both ends, doesn't it? So it's continuous from, yes. Symmetry. Ooh, what kind of symmetry? Y-axis. End behavior. The limit of f of x. What do you notice about the end behavior on this one? It's the same at both ends, isn't it? So look how I'm going to write this. I'm going to save myself just a little bit of work. And which way is it going at both ends? Towards infinity. So if they're both the same, you can write them as one equals the other, which equals whatever it is. Okay? Increasing, decreasing, or constant. Both. So which is where? Yeah. It's decreasing here and increasing here. So from negative infinity all the way to 0, and then from 0 to infinity. Okay? So decreasing, negative infinity to 0, increasing 0 to infinity. Okay? We've done quadratic, and now guess what we're going to do? We're going to cubic, aren't we? So in cubic, f of x is what? X to the third. So we need to make a table of values. X, f of x. -2, -1, 0, 1, 2. All right. If I plug in -2, what comes out? Thank you. -8. -2 cubed is -8. -1, 0, 1, 2. All right, so let's graph those and see what they look like. So it's that kind of twisty, snaky S one, isn't it? All right. Domain and range. I think y'all should handle this one. See if you can fill in the domain, the range, the x and y intercepts, all of these. See if you can do these. Give it a shot. I'll give you a few minutes, and then we'll see if you get them right. Let's see why my husband keeps. Okay. Let's see. Sorry, guys. My husband doesn't know how to tell time. Meaning he forgets I'm still actually at work and have to do stuff in my job. So he works from the house. He does work. Sometimes he works late, but man, it's not the same as being a teacher. It's like working fast food. There's never a dull moment, is there? I worked fast food when I was in college, and before I get a real job that paid. By that I mean one that actually paid me money, because fast food doesn't pay very well, does it? No, it kind of sucks. It's like serve your time. But I'll tell you what it will do, is working fast food will make you humble and appreciate people who do work fast food, and you will never be rude to them again, because people will be ugly to you when you work fast food, and it's not okay. So I try to be very nice to the people who work, especially the window. They always stuck me, I'm good at math, so they always stuck me on the drive-through window because I could make change in my head. So, and that's like the most fast-paced place in the entire restaurant. You guys stay on top of it. So I would just add stuff in my head and tell people what their cost was. Now they do it all on computer for you. We didn't do that. We didn't have that way back then. Huh? No, I didn't have to write it down. I'm not that old. But yeah, you didn't, it would press in. You could, it didn't automatically, it didn't automatically give you the change out like it do that. I know. All right, domain. What's the domain here? Moving on. You're fine.
My teacher this morning,
Mm-hmm.
Mr. Nolan,
Yeah.
was talking about keywords.
Yes, I was. I was his teacher. I know. Not the only one. Mm-hmm. There are several people who work here who I used to teach back in the day. Mm-hmm. So, hey, we all stay ahead. Yes?
Have you always teach the same subject?
No. I used to teach all math, but I have a certification in physics. So when Miss Lawrence left, I took over the physics. So I don't know. You guys probably don't remember. Some of you might. No, you're juniors, aren't you? Yeah, you don't remember Miss Lawrence. She wasn't here. She'd already left last year. So I've taught everything under the sun. Algebra 1, Algebra A, Algebra B, Geometry, Algebra 2, with trig, regular Algebra 2. Huh?
I thought you said algebra 8. Like, help me.
I did. Algebra A, Algebra B. They used to split algebra into A and B for the kids who needed it. I taught those. Yeah.
I said 8.
Oh, no, yeah. Algebra 8. That'd be like Cal 3. Okay? Yeah, no. Pre-Cal, statistics, you name it. I've taught all of it. I think the only class here that they offer that I haven't taught is finite. Yeah, that's about it. Finite math, it's a newer class that they teach. I've taught chunks of it before in other classes that they no longer offer. But, yeah, no. I used to be the head of the math department. I gave that up. Miss Williams. I went to Mr. Garth and said, please make somebody else take this. It just takes time that I don't have because I have a lot of different preps. I have 4 preps, 3 of which are AP classes, different AP classes. So I have 5 AP certifications, so yeah, it's a lot. All right, domain. What's the domain? All real numbers, negative infinity to infinity. Range. All real numbers, good. Negative infinity to infinity. X-intercept and Y-intercept. 0, 0. This is about the point where somebody says, is it always going to be 0, 0? And I say, no, not necessarily. Same with domain. Continuity. Is this thing continuous? Yes. Over what? Yep. Symmetry is indeed origin symmetry. Yes, organ symmetry. Yes. And behavior. The limit of f of x as x approaches negative infinity was what? And the limit of f of x as x approaches positive infinity was increasing or decreasing? Just increasing. From where to where? All right. Just when you think the next one's probably going to be x to the fourth power, it's not. It's absolute value. Absolute value of x. X, f of x. Negative 2, negative 1, 0, 1, and 2. What does absolute value do? Makes it positive, doesn't it? So if I plug in negative 2, what comes out? Negative 1, 0, 1, and 2 is 2. So what is this guy going to look like? A V. Yes. It's like you took the lower half of the identity function that's in the third quadrant and swung it up to the second quadrant, isn't it? Go ahead and when you get it graphed, fill in all of the things. You guys can do that. So fill in all of your domain and range and all that fun stuff. Check them as you go. So far, so good. You start to feel a lot more comfortable with this. It gets easier, doesn't it? Practice, practice it, practice it. And then finally, increasing or decreasing? Both. Right. Shouldn't this all be exactly the same as it was for the parabola? Don't they pretty much act the same way in general? And behavior, everything? Increasing, decreasing intervals, all that. You'll notice that this is exactly the same characteristics as the parabola. So far, so good. So now let's really change things up. Square root, or a radical function. This is f of x equals the square root of x. This one's going to be a little different. Because number one, what do we have to do to, don't we have to restrict the domain on this guy? What kind of domain are we not allowed to have for this one? Negative numbers, which means we need to start at 0. What is the square root of 0? 0. And then I'm going to go to 1. What is the square root of 1? And then I'm going to skip to 4. Why? Yeah, because I don't want to deal with decimals, do I? Square root of 4 is? And if I wanted to, I could do 9 and 3, couldn't I? So let's graph this guy and see what we get. This is the first one we've seen with the restricted domain, isn't it? So 0, 0, 1, 1, 4, 2, and 9, 3. It's going to curve out like this and keep going. Now that you've seen that, can you do domain and range and all those other things for this guy? I should be able to hand you a picture of any type of function and you tell me domain and range. If you see it, you should be able to describe it. Okay? So just to be sure, what is the domain of this function? Yep. Greater than or equal to 0. X is an element of the reals, right? Or we could say from 0 to infinity with a bracket. What about range? Yep. Except with y. Y-intercept. Okay. 0, 0. X-intercept. Continuity. Now, some of you are going to argue with me on this. Continuity, is this thing continuous? Yes. If we restrict the domain, it is. Remember, we restricted the domain, didn't we? So once I put my pencil down, does it keep going? Yes. But only because we said you can't even have this other half of the guy, can you? All right, so the answer is yes. Over what interval? 0 to infinity. Does it have symmetry? No, none. End behavior. This one's tricky. Guys, the limit of f of x as x approaches, you cannot say negative infinity. Does x approach negative infinity in this? What's the lowest it goes? So we have to say as x approaches 0. What does this function approach as x approaches 0? What does y approach? No, 0. It's going to the point 0, 0, isn't it? However, on the other end, is it approaching infinity? Yes. And so as x approaches positive infinity going this way, what does it approach? Infinity, doesn't it? Increasing or decreasing or constant? It is increasing over the interval from, and this time we have to use parentheses, not bracket, parentheses 0 to infinity. All right. Starting to get the hang. Reciprocal or rational. F of x equals what? Someone impress me. What? You impress me. 1 over x. Reciprocal means to flip over, doesn't it? Good. So what is this guy going to look like? We do have to restrict the domain on this one too, but we only have to restrict the domain just a little bit. What domain restriction do I have here? 0. Yes. Why 0? Yes, if it's 0, it's undefined. So we can do negative numbers. We can do positive numbers. We can't do 0 because at 0 it is undefined. You know what that means? That means there is a vertical asymptote at 0. So when we graph this, we better be aware of that. So if I plug negative 2 into this function, what comes out? Negative 1/2. If I plug in negative 1, what do I get out? Negative 1. If I plug in 1 and plug in 2, 1/2. That is going to help me graph this guy. All right. So at negative 2, it is 1/2. At negative 1, it is negative 1. And we know we have a vertical asymptote right here, don't we? Do you remember what functions do near an asymptote? They either go towards infinity or negative infinity. Which one does this look like it's going towards? What's the trend in the dots? Going up, aren't they? So this guy is going to trend, oops, it never actually hits the asymptote. It trends up, doesn't it? What does it look like it's doing the other way? Is this ever going to cross the x-axis? No, it isn't. It's not, is it? Oops, guys, what did you just let me do? Somebody say something.
I did the same.
Yes. I just merely put it in the wrong quadrant, wasn't I? Thank you. Okay, negative 1 and negative 1/2. Thank you very much. It should be doing what? That. Yikes. I never claimed to be perfect. Next time you see me doing something stupid, go, Miss Duffy. Negative negative goes in the third quadrant, doesn't it? Yeah. All right, where else am I going to have a graph? Yes, first quadrant's going to do this, isn't it? It's still never going to cross the x-axis, though, is it? All right, this is going to affect our domain and our range, isn't it? We got a big old hole for the domain, and we got a spot in the range, don't we? All right, so let's do domain. What is the domain of this guy? Everything except what? 0. So x, such that x cannot be 0. If you wanted to do that one in interval notation, you would have to do it as from negative infinity to 0, and then from 0 to infinity, wouldn't you? Range. Yeah. Y such that y cannot be 0. It doesn't, y, element of range. Real is here. And this would be the same thing, wouldn't it? Y-intercept. Okay. X-intercept. Continuity. No. It's continuous everywhere except where? 0. So really what we're going to do is we're going to say it has an infinite discontinuity at what? At x equals what? 0. And so we can leave it at that. The implication is it would be continuous everywhere else, wouldn't it? Symmetry. Origin. That good old organ symmetry. And behavior. What is the end behavior of this guy? As it gets closer and closer and closer to infinity or negative infinity, what is it approaching? 0, isn't it? Isn't it getting closer to the x-axis? Well, what is the value of y at the x-axis? 0, isn't it? So both of these are 0. Is this guy increasing or decreasing? Take a look at it. It is decreasing everywhere, isn't it? Except at 0. So we say this is decreasing, but we can't say all real numbers, can we? We have to go from have to write it like that because it is clearly not increasing or decreasing at 0. Oop, I think we're to the last one, aren't we? Woo! Greatest integer is one that you should have seen it. It's a step function, but most of you probably aren't familiar with it. That is f of x equals, here. That is the symbol for a step function or greatest integer. Greatest integer is called a step function. It is also sometimes called an elevator function. Now, I'm not going to give you a table of values. I am, however, going to explain to you why it's called a step function or an elevator function. I'll tell you why it's called an elevator function first, and then we'll graph everything, and then you'll see why it's called a step function. Greatest integer function basically says it can only be an integer function value. It can only equal 1 or 2 or 3 or -1 or -2 or -3 or -4 or 0. It cannot equal any of the values in between integers. I call it an elevator function, and a lot of other people do too, because what happens is it automatically moves the function. If it's between an integer function, it moves it down to the nearest closest integer. Now, why elevator? I want you to think about this analogy. If you were to get stuck between the first and second floor in an elevator, and they had to get you out, they are not going to raise you up to the second floor, are they? They're going to let gravity help, and they're going to lower you to that floor. Now, if you're on the elevator and you actually make it to the first floor, it's going to open at the first floor, isn't it? But if you get part way up, it's going to bring you back down to the first and open at the first floor. So anywhere between, so the greatest integer function of 1.6 would still be 1. The greatest integer function of 3.8, you didn't make it to 4, did you? So what's it going to do? Bring you down to 3. If you make it to 0.5, you didn't make it to 1, did you? So it's going to bring you down to 0. Now this also works for the negatives. If you get to -1.5, no. Why -2? Number line goes this way. So if you're between -1 and -2, the next floor down would be the next subfloor basement floor, wouldn't it? So you just got to think gravity. That's why I say elevator function. It helps you remember what's happening. Now, if it is only at the integers, and you develop the graph, it's 1 until it gets to 2, and then what happens? It hops up to 2. It stays at 2 until it gets all the way to what? Now all of a sudden it's at 3, isn't it? And then it's at 4. What's your picture? What it looks like? Staircase going across the graph diagonally. Okay. We'll talk about that because it's so much so that we pretty much say it's not. But let's look at this. Does everybody understand how greatest integer function works? So at 0, it is 0. It stays at 0. I'm going to do this in a different color so you can see it. It stays 0 until it gets to here. And then at 1, where does it go? Yeah, it goes up to 1, doesn't it? So now it's here. It stays at 1 until it gets to the next integer, at which point it hops up to that integer. Stays there until it gets to the next one, and so on, and so forth. It is a piecewise function. and so on. And it's going to continue to go this way and that way, isn't it? Do you see why it's called a stair function or step function? Looks like a set of steps going up or down. Now, this one is going to require you to actually do some thinking. If I were to collapse this entire function all the way down to the x-axis, in other words, if I were to squish it this way, how much of it would be covered? All of it. So what is the domain of this function? All real numbers. Yep, for every open circle, there's still a closed circle on the x-axis, isn't there? However, comma, what is the range? 0, 1, 2, 3, 4, -1, -2, -3, -4. What do we call those? All the integers. It's all the integers, isn't it? So how do we write that? Y, such that y equals n, where n is what? An integer. Okay? Y-intercept. It does have one. Yeah, deny. Who's trying to hook up to my device? Yeah, no. Hold on. Move. Hooking up to mine. Nobody's projecting anything else. I don't know what they're trying to project, but they're not projecting mine. All right. Y-intercept is 0, 0, isn't it? Right here. X-intercept. Ooh, continuity. Does this thing have any continuity? It's got a whole bunch. It's a big old step function, isn't it? So it's got jump discontinuities at every single what? Integer, doesn't it? Symmetry. You want to say it's, you kind of want to say origin, don't you? But it's not. Do you want to know why it's not origin? One circle's open and the other one is what? Closed. So when you spin it around, it wouldn't quite match up. So it has none. End behavior. This one's actually easy. Easier than you think. You're going to try to make it hard. The limit of f of x as x approaches negative infinity. Where is this guy going? To the left? Negative infinity, isn't it? Think about it, guys. Look what we said. This thing is going to keep on going both ways, isn't it? So to the left, it is still going towards negative infinity. The limit of f of x as x approaches positive infinity is positive infinity. Is this guy increasing, decreasing, or constant? Both. So guess what? It is constant in between, but then it is also increasing. So we just don't even, it's too complicated to try to write it as that. It's really weird. All right, let's finish up. Transformations. Yeah, you're almost done. I got 3 more minutes. I'm taking them. Rigid, you're not having any homework. Think of it as a trade-off. Rigid transformations change only the position of the graph, while it does not change the size or the shape. I can very easily describe to you what that's like. My hand is a graph. I can move it like this. I can move it like this. I'm moving the position. However, is my hand getting bigger or smaller? No, it is not. Is my hand, so my hand does not change shape either, does it? Still looks like a hand. Okay, that's the difference. These are left or right, up or down. Okay, so we have vertical transformations.
Good afternoon, Austin High School. We had another great day here at Austin High School.
All right, we'll stop there.
Announcement, students, we still will be selling Austin versus Decatur